Hi everyone, welcome back again. Let us see some more problems related to probability. Okay, uh, I have a problem like probability that a leap year will have 53 Sundays. Now, a leap year has got 366 days. Okay, now which comprises of 52 weeks and 2 days. Now, how this weeks can be put? So that is, we have Sunday and Monday, again Monday and Tuesday, and so on. You have this 2 days like that. Now, this again, if you have this, you will have the total number which is 7. Such type of pairs. Okay, Sunday, Monday, Tuesday, and so on. Now, the possible which is 7. Okay, now which is asked is favorable, which is outcomes, which is 2 out of that. So that is 2 by 7. So the answer will be 2 by 7. Okay, if you have any queries, post it. Okay, let us see some of the problems related to it again. Now, contains a box contains. I have a box which contains 3 white and 5 black and 6 red. Okay, balls. Okay, this is placed in box nicely. Okay, we have 5 numbers which we see. We don't what is there, only the numerical values which we concentrate on that. That's it. So 3, 5, and 6. So total number should be 14 out of it. That first thing you have to know. Okay, let me continue with the problem again. If a ball is drawn at random, which is that the probability that it is either red or white. The question arises now, you have to find the probability. You're drawing that, okay, in a box which contains these many 3 colors: white, uh, black, and red. Okay, and he is asking only the balls which is trying to know is red or white. So the total numbers which we have is 14. So red and or white. So or red or white. Or is again an operator here again. Okay, which is a plus symbol here in mathematical, which you use as plus symbol. Now red, we have total which is 6. Okay, and white which we have is 3. Okay, that's what uh, we have the data. Individually you can write as 6 divided by 14. Okay, and 3 divided by 14. Okay, so or becomes add these two separate events, so which is 9 by 14. So this is the result. Or further you can simplify if you want. Okay, or uh, further I don't think so, because this is 2 into 7 and 3 into 3. So 9 by 14 is the perfect answer for this. So hence we solve this problem. If you have any queries, yes, is there any shortcut method? Now, see, you have this here. Uh, there is no as such a shortcut for this, but I can say here, uh, you have to. understand the question. Here it is 5, 3, and 6, which is in a box. So add this. So you get 14. Okay. The requirement which is red, you have that is 6 and 3. That's it. So directly if you put, if you add up these sum, you get 9, get 14. That's it. There's no as of this. Uh, any queries? Uh, okay. I hope this clarifies your doubts. Okay. So let us see next problem, how to solve it. Of course, I'll be taking these examples again and try to explain in binomial as well as Poisson's or whatever method is suitable for solving this problem. Okay, further. Now, let us take one more example. Again, a box contains two white and two black balls. This is in one box, one such of box. This is box 1. I'll label this as box 1. I have another box. Okay. This contains two white and four black. Okay. So another box. I have. If one ball is drawn from each, okay, what is the probability that they are of same color? First, let to solve this problem. First, what you are supposed to do is you add up these box total number of balls, whatever the color may be. Add that first. So this is 4. The box contains 4 balls. Again, here box contains 6 balls. So it is neither less than that or more than that. So that is fixed. So first you have to fix that value. Okay. So this is the maximum possibility. That's it. Okay. Now drawing a ball, one ball from each. So and again, what is the probability that of they are of same color? So balls drawn white, okay, white alone. If I consider that, so the probability that is 2 by 4 and as well as 2 by 16 6. Why? Because this box contains white in it. So you have to multiply this. Okay, this is the maximum possibilities. So I get this as 1 by 6. This is for white. Okay, as well as for black. Okay, so that will be again 2 by 4. Okay, and this is 4 by 6. But the box has got 6. So that's the possibility. So that is you get 1 by 3. This part of the problem which you have done is uh, okay. I got a query saying that how the answer is 1 by 6. So here white if I consider, okay, white is available in box 1, okay, as well as in box 2. So ball is drawn at random, okay. You might not know which color is it, okay. So the white of this and this is this. So when you multiply this, I get this 1 by 6 as answer. I hope you understood this. As well as same for black case I've done. Okay. Now the another part of the problem which is of same color. So same color means this adding up these two will result to 1 by 2. So this is the solution of the problem which I've explained. Okay. Let us continue with next problem If you have any queries, you can post on. I can wait for that. Okay. So since I didn't get any queries, okay. Now let us see next part of the problem. I hope everybody understood this. How to do this? Okay. Uh, in a cricket match, okay, um, batsman hits a boundary which is 6 times out of 30 balls. Okay, 6 times out of 30 balls he plays. Okay, you have to find the probability that he did not hit a boundary. You have to find the probability that he did not hit a boundary. Now, how do you solve this? Okay, so number of times a batsman hits a boundary, which is 6. Okay, so we have that 6 is the number. Again, the total number of balls, okay, played is 30. Is 30. So left is should be that is 30 minus 6, which is 24. Okay, so the question arises here, which is did not hit a boundary. So did not hit a boundary, which is P, which is 24 by 30. So which results to 4 by 5. Okay. Any queries? Okay. So I hope this is sustainable, right? So we'll move on to next. Okay, I got one query. How did not hit boundaries in 24? Okay. The answer for this is now in the question itself, you have saying that the question itself you have saying that you have 6 times out of 30 balls. So 6 is the number of times a batsman has hit a boundary. So 6 is the numbers. So 24 comes out of total number of played by a batsman is 30. That is 30 minus 6 will be 24. So that is the answer. So okay, here it is 24. So that's what I have answered for your 24. Okay, and what is 24 by 25? No, it's not 24 by 25. It is 24 by 30. Okay, 24 by 30. Okay, 30 is the see here. Uh, your what you are looking at is which is favorable. That is M. This is N is number of possibilities. So M by N. So that is 24 by 30. Fine. Any queries? Shall I move on to next problem? Okay, fine, fine. Then. Yeah. Uh, okay, thank you. So let us move on to next. I have 1,500 families. Okay, 1,500 families with 2 children were selected randomly, and the following data were recorded. Okay, that is number of girls. Okay, in a family, girls in a family. Okay, 2, 1, and 0. Okay, and that is a data which is given number of girls in a family. That is 2, 1, and 0. And number of families. Okay, that is 475 and 814 and 211. Okay, now this is the question. The n, which is uh, 1500. So the given data is correct. So when you add these, so this is 1500. Okay, there's no problem with the problem itself. Okay, so the question is correct. Okay, now let us compute the probability of a family chosen at random having two girl two girls and one girl and no girl. Okay, so also we have to check whether the sum of the probabilities is 1 or not. Okay, we'll see. So first the solution for this. Now when you add all this, the same thing which I've done in the previous problem. First what you have to add up all those which is contained in one event. You are adding it, so I get that is 1500. Okay, now the first question arises of two girls. Okay, so number of families having two girls. So here you have the numbers which is 475. Okay, and out of which is 1500. So m by n. So when you calculate it, you get 19 by 60. Okay, so that's that. Now, any queries of first one? No, right. Okay, let us. So I have answered for the first one. Any queries? No, right? Okay. Now, if I have, now let us concentrate on the second part of the problem. Again, this is also same. You have one girl, that is 814 divided by 1500. So this, if you compute it, you get 407 divided by 750. So one. No girls. So no girls is 211 divided by 1500. Okay. Now let me put in a nice format any queries. No. Okay. So see here. When you look at this problem, this is for two, this is for one girl in a family, this is no girl in a family. In the question itself, you have the answer. So this, when you add these results, okay, so these results, when you add these results, so this should be 1500 divided by 1500, which is 1. So hence we have proved that the sum of all these probabilities is 1. Okay. Any queries? No. Right. Shall we move on to next part of the problems? There are 3 points. Okay. There are 3 points. Okay. I've got a query again. Is there any probability which is more than 1? No. which doesn't have, if it is more than one, it is not a problem at all. I mean, it should not exceed. See, in a box, for example, if you have the total number is 100, okay, it should not exceed 100 unless you put, then if you add one again, it should be 101 in the box. So it cannot be more than one. So 100% is 100. 100 divided by 100, which is 1 itself. So that your query, I have given the answer for that. Okay. So, okay, we will move on to next problem. Now, three coins are tossed simultaneously. Three coins are tossed simultaneously 200 times. 200 times. Okay, with the following frequencies of different outcomes. Okay, the outcome which is given, outcomes, three heads, okay, two head and one head and no head. Okay, these are the output and the frequency, how frequently it occurs. So three heads occurring is 23, correct? And this is two heads, which is 72, and one head, which is 77, and no head at all, which is 20. Now, uh, let us see that if three coins are simultaneously tossed again, let us compute that probability of two heads coming up. Okay, let's see that how to do it. Number of two times head coming up. So this is the thing, two heads coming up, which is 72. How frequently it occurs? 72. 72 times. Two heads coming up is 72. So how many total number of tosses has been done? Which is 200. Okay. Again, if you add this, so this should result to 200. Okay. Please check. This is 72, 100, is 100, 200. Okay, you're getting right what I wanted to say. So now you have to find the probability of this. So this is 72 divided by 200. This is the result. Okay, which you can further simplify, which is 7 by 9 by uh, 25. You are able to understand this? Any queries? Yes. Um, Fine. Let me proceed to the next problem then. Okay. Any guesses of if suppose if I have three head, okay, if I get, let me extend that to the problem. If I have three head, so three head, again this is 23. Again the total number which is this, so it is 23 divided by 200. Again one head if I consider 77 divided by 200. Again no head, it is 28 by 200. Again if you add all this, 23 by 200, and this is 72 by 200. So this results to 1. I hope the one which was asked in the previous problem, is there any probability which is more than 1? So it is not possible, right? This proves like that. Otherwise, the question is wrong. That's it. Grace marks. Okay, fine. So we'll see the next problem. Okay. Now, if I have to know the opinion of a student about the subject statistics. If I want to know the opinion of on the subject statistics, okay, a survey of 200 students was conducted. The data is recorded in the following table, right? So the opinion matters, right? Opinion, okay. The number of students, okay. The opinion is like and dislike, okay. The number of students, that is 135 and 60. Now, if you look at this data also, when you add this 135 plus 65, that results to 200, right? So the question is correct. Okay. Now you have only two things happening on the opinion, that is like and dislike, no otherwise. Okay. The problem itself is so simple. Okay. Uh, did you understand this problem? Right? I hope so. Okay. Then let us find the probability that the student chosen at random, okay. That is first one, like statistics, two does not like it, that is statistics, okay. So again, this is liking, this is 135 by 200 of that, and this is 65 200. Again, if you see these results, 35 135 by 200 plus 130, 165 divided by 200, which results 100. So all I want to say is this, which the end results, okay, which you get and which you try to solve, okay, whether it is event occurring or not occurring. So that is an event, okay. So we'll further see some of the problems, okay. Please tune into and please do mail us, and as well as do subscribe us. So please do give me some comments on this, how was the video is about, able to understand or not understand, or uh, thank you.